Welcome everyone to this presentation. The topic today is differentiation, a topic in calculus, and in particular we are looking at maxima. The question we have here today reads, in the figure below, PQRS is a rectangle, PQ is 30 centimeters, so the whole of this length, and then PS is 10 centimeters, so right here. The unshaded portions are cut off, leaving a parallelogram ABCD. So we have the shaded part is a parallelogram which is left after the remaining parts are cut off, and then you're told given that line BQ is equal to DS, which is equal to X, BQ is here, which is X, which is also equal to DS. DS is right here, X, and then it continues, and line CQ is equal to SA, which is equal to 3X. So we have CQ 3X, SA is also 3X, and then you are asked to find the value of X when the area of the parallelogram ABCD is maximum. Now, because the question requires us to get the value of X when the area of the parallelogram is maximum, then we are going to form an equation of the area of the parallelogram in terms of X. Area of the parallelogram A will be obtained as follows. We get the area of the entire rectangle, and then we will subtract the areas of the parts which were cut off. So we'll have area of the parallelogram, the length of the rectangle is 30 times the width of the rectangle, 10. And then we will have to subtract the area of this remaining part. So what is left here is 30 minus 3x. Remember, this length is 3x and the whole of this is 30. So we subtract 3x to get this length. And then here, this width, we have 10 minus x. Remember, the whole of this length is 10. If you subtract x, you'll have 10 minus x for that length. So the shape here is a right angle triangle, and it should be equal to this other side, because here also we have 30 minus 3x, and here we have 10 minus x. So what I'm going to have here, we are going to begin by subtracting these two areas, this triangle here and this triangle here. So we'll have minus 2 times a half base times height, and the base for this triangle here, and have it as 3x. So a half times 3x times the height is x. I'm multiplying by 2 because they're two triangles and they're equal in that they have the same base and the same height. Now once we're done with that, we are also going to consider these other two triangles, this triangle here and this triangle here. So because they are two and they are equal, we will have to multiply their areas by 2. So 2 times a half base, and the base half times the base. The base is, we can consider 30 minus 3x as the base and 10 minus x as the height. So what you're going to have is a half. For the sake of uniformity, let me use the dot here. So we have times the base 30 minus 3x times the height 10 minus x. Here we have 300 minus, and then inside the bracket we'll have 3x squared plus, here again these and these cancel. Now when we expand this part here, we are supposed to be having, so this is 300 minus 30x, and then minus 30x, that is a multiplying negative 3x times 10, and then negative 3x times negative x, that is plus 3x squared. hoping that we know how to expand. So I've just multiplied 30 by 10 to give us 300, 30 by negative x to give us negative 30x. Then negative 3x times 10 is negative 30x, and then negative 3x times negative x, positive 3x squared. So simplifying this further, we will have 300 minus, so this and this becomes 6x squared, and then plus 300, and then here we have minus 60x. Opening the brackets, we are going to have 300 minus 6x squared minus 300, that is, the negative multiplies all the values inside the bracket, plus 60x. So 300 and 300 subtract, so that finally we have negative 6x squared plus 60x. So this is A. Remember, we are required to determine the value of x when the area of the parallelogram is maximum. So already we have an equation of the area of the parallelogram. When the area is maximum, we will have the derivative of the area with respect to x being 0. We will differentiate this equation with respect to x, and therefore we will have the derivative of A with respect to x being equal to negative 12x, that is 2 times negative 6, and then the power reduces by 1, and then plus, here we have 60. Now this is equated to 0 because it's at maximum area. Then from here we have the equation. If negative 12x crosses, it becomes positive, so we have 12x is equal to 60. And from here, therefore, we can conclude that x is 5 centimeters, just as had been required in the question. And now with that, we mark the end of the solution to this problem. I want to thank you for watching. Hope to see you in the next video. Bye.